Alrighty, here we are, acid-base indicators. So an indicator is something that we can add to a solution in order to determine pH. So it'll tell us a range for a pH because when the solution is added, when the indicator is added to a solution, it'll result in some type of color change, and that's what makes it an indicator. And we have plenty of indicators. We have decided to put them all on a chart. It's pretty simple. So one of the most commonly used indicators in a lab is going to be called litmus. That is tiny little thin sheets of paper. They are either blue or red. If I think my solution is acidic, I'll use blue litmus paper because that blue paper would turn red. And if I think my solution is basic, I'll use red paper, dip it in, and it should turn blue. So it turns opposite. Acids are red and bases are blue. And it has an indicator embedded into the paper. The reason we like litmus is because it's a dip test, so it does not affect the solution at all, which is why it's one of the more common ones. There's also something called pH paper, which is usually like this ugly goldenrod yellow color, and that gives us a little bit more specific pH ranges. I think it's a few shades of green, some blue and purple, some red and orangey colors, and then you hold it up to the little tube that it comes in, and it'll tell you like sort of close to the pH. So we like these because we don't actually have to add them to the solutions. It's just a dip test. So some of our indicators can be found on table M, and these are things that we would add to our solution. So technically they're altering them, but for the most part, we're okay with this. What you could do is add a small amount of your solution to a test tube and then add a drop of indicator if you can't alter your original solution. So if you can see on this table, we have ranges for each of these things. So the indicator called methyl orange, if the pH is 3.1 or lower, the solution would turn red. And if our pH is 4.4 or higher, that solution would turn yellow. It's not like a specific pH turns at a specific color. It is a range. So usually we want to use a few different indicators because a lot of these ranges are very broad. Like this one, for instance, 4.4 all the way up to 14 is yellow. That doesn't even tell us if our solution is acidic or basic. So this indicator is really good if you're working with stronger to medium level acids because it'll kind of give you an indication whether it's red or orange. Bromthiamyl blue is blue if it's basic. And that's just basically it. It's blue if it's basic, and it'll be yellow if it's acidic. Phenolphthalein, that's a tough one to say. Phenolphthalein. This is most commonly used in titrations because it's coming in close to a neutralization point, not exactly, but close. And then here we have litmus, like I spoke about before, bromocressyl green. These things all have different ranges. Like this one is only going to tell you if it's really acidic or kind of acidic, and then everything basic is just going to be blue. So when we use indicators, we want to use more than one typically, because that's going to give us a better idea of where our pH is. So here's an example of methyl yellow. I've had to put it on a gray background so you can see the yellow here. If you look here, the approximate pH range for color changes on methyl orange, it's going to be red when the solution is 3.1 or lower, and it's going to be yellow if it's 4.4 or higher. So if you mix red and yellow paint, you would get orange. So that means it's orange in between that range. So here, bromthiamyl blue is going to be yellow if it's 6.0 or lower, all the way to 0. It's going to be blue if it's 7.6 or higher, all the way up to 14. And then if you were to mix these colors, that means it's going to be green, somewhere in the middle here. Phenolphthalein is either colorless or pink. There's no other options. And then same with litmus. There's no other options. It's either red or blue. And then these guys are also going to have transitional colors in the middle. So between yellow and blue would be green. It does require a tiny bit of art skills, but you can kind of see the example here for methyl yellow. That's all there is for indicators. It's pretty straightforward. You just add a drop and read the color chart. And if you don't get anything specific, like here, there's almost 10 points on your pH scale, I would take my solution and I would add another indicator to narrow it down if I had gotten yellow as my result, because it doesn't even tell me if it's acidic or basic. These are not really used all that much just for a general pH test. Usually you would just use pH paper for that, but there are some instances where you would use indicators for this purpose. More on neutralization and titration to come, which is primarily where indicators are used in a lab setting. So if you have any questions, leave them in the comments and I will do my best to get back to you.